This is the help video for the Unit 4 video study guide. We're going to be going through the starred problems. You will notice many of these problems are a review. This is in preparation for your semester 2 final. So it says, note the lines that are parallel and the given equation. Solve for x and find all possible angles in the diagram. So things you need to remember here are the 4 different angles made by parallel lines and their properties. First one is alternate interior angles. And when lines are parallel, those are congruent. Alternate exterior angles. When those are parallel. When lines are parallel, those are congruent. Corresponding, one in, one out, same side. When those are parallel, they are congruent. Then you have consecutive interior angles, also known as same side interior. When those lines are parallel, these are supplementary. So those are your 4 type of angles. You come over here and you establish what kind of angles are these. And this is one in, one out, same side. They are corresponding, therefore they are congruent. Angle equals angle. The green would be a set of consecutive interior, which would add up to 180. So you would do 11x plus 13 equals 12x plus 6. Of course, you solve for x. And then you plug it back in. And then angles that are going to be congruent to that, of course, are going to be vertical angles will be congruent. You will also have armpits of the Z going on here, alternate interior angles. So you can, this also congruent. That one as well as congruent to that one. So those blue are all going to be congruent. And of course, you want to watch out for linear pairs, which add up to 180. Then you can get this angle, which is the same as this angle, vertical, armpits of the Z going this way, which is the same as this angle, which is the same as this angle, corresponding to the original, armpits of the Z, congruent to this angle, congruent to this angle. Now, unless you know that this is a bisector or some other relationship, you cannot get these 2 separate angles. It does not say it's a bisector, so be careful with that. Graphing of lines. Negative x equals -2. We need to change this to a positive, so we're going to divide by -1. So I get x equals 2. Let me show you what this is not. This is not this. Ta-da! Because that is the single point, 2, 0. We want all the points where x is 2. So it's important that you graph a bunch of points, and then you will see 2, 0, 2, 1, 2, 2, 2, 3, etc. When you graph those points, you will see exactly what kind of line it is. Says, write the slope-intercept form of the equation of the line described, graph the original line and the resulting line. So in number 7, the original line is y equals -2/9x minus 5. So I'm going to graph that first. y equals mx plus b. Our b is going to be -5. And our slope is -2/9, so it's a downward slope. So there is our given line. That is y equals -2/3x minus 5. Now, we want a line. Our resulting line is perpendicular to the given line and goes through the particular point 2, 5. So just as a reminder, parallel slopes, slopes are equal to slope. Perpendicular slope, slope times slope equals -1. So if our given slope is -2/9, our perpendicular slope is +9/2. So we have a point, call it x1, y1, and we have a slope. So we're going to use point slope equation of a line. Y minus y1, slope x minus x1. Plug everything in. This 2 goes right here. This 5 goes here. This slope goes here. And you bring down the equation around it. You want to change that equation to y equals mx plus b, and then graph y equals mx plus b. Obviously, you start by distributing this and then graph. And then your resulting line will be perpendicular to the original line and go through that point. It says find the missing length indicated, which is IK. Really simple here. You're going to notice, since these are equal, that makes U a midpoint. Since these are equal, that makes T a midpoint. That makes UT a mid-segment. And the mid-segment is parallel to this side, and it's also half. So this is 1 bunny hop, 2 bunny hops. So your thing equation is 2 of TU equals 1 of IK. Use that to solve for X and plug it back in. Each figure shows a triangle, shows 2 medians intersecting at a centroid. Find X and all lengths possible. So taking a look here, since I have a centroid, since this is a centroid and this is a centroid, what you need to remember is that centroid makes a 1-to-2 ratio in the middle. So this is 1 bunny hop and 2 bunny hops. This is also 1 bunny hop, 2 bunny hops. Keep that in mind when you're working with these equations. So the one on the left, what are we given here? We are given F to U, which is the blue, and we're given F to S, which is the green. And then what's there but not given anything is S to U, which is the red. So we know a couple things here. We know that the green equals to the blue plus the red. That's why it's important to color code this. It'll kind of help you see what's going on. And you're like, but wait a minute, I don't have the red. So you have to ask yourself, what can I do to define the red? Well, I know that the red is whatever the blue is divided by 2. And then that information will give you the red. So color code these, you'll be able to see the relationship between the variables, and then solve for X, and then solve for all possible segments, which will be the blue, the green, and the red. It states if the triangles in each pair are similar. If so, state how they are similar and complete the similarity statement. So we're checking to see if the triangles are similar. When you have overlapping triangles, your first step is to pull them apart and to check to see if they are similar. So there's the blue and green. So the blue, this is 33. This is 33. When I add this up, 33 plus 121, 154. Look at there, 154, 154. Okay, let's see what these have in common. Well, first off, I have ratios which are equal. Taking a look here, 33 to 154, both are divisible by 11. That's going to be 3. And here it's going to be 14. 11 goes in there 14 times. So it's 3 to 14 is my ratio, and 3 to 14 is my ratio. So my side ratios are equal. So I have a pair of side ratios and another pair of side ratios. They also share this angle right here, because it is a reflexive angle. So triangle VUT, VUT must be similar to triangle VCD by side angle side similarity. So you need to recap that yourself in this explanation. We're going to match and mirror. match and mirror the sides. And since this is a whole side, I'm going to pull the triangles completely apart. So I'm going to have one, I'm going to blue triangle separate from the green triangle. Blue triangle. Green triangle. Now, I know they're similar simply because, one, it tells you, ta-da! And technically also, this would create parallel lines if they are similar. So this whole side here is 7x plus 5. My whole side here is 60. And this whole side here is going to be 36 plus 9, so it's 45. On the green, this side is 32, this is 48, and 36. Then they are similar. You choose your ratios. Something over something equals something over something. Cross multiply and solve. $25, you want to match and mirror. Match and mirror. So this is a whole side here. What matches there is going to be the 27. And then 16 will match with that segment that you don't have, but you can see 27 minus 15 gets you 12. Now you have matching segments. Now you just mirror. You can go left to right, left to right. You can go small to large, small to large. Again, how you start doesn't matter, but how you finish does.